Right, welcome to Physics Tips for Cambridge Students YouTube channel. Today we are going to be focusing on how to score good marks on the table that is in your AS Physics practicals. Right, so we're also going to look at the graphs. Okay, how to score good marks as well on the graphs, as well as the calculations that revolve around that graph. Without much further ado, let's get started. Right. So on the table, usually a table is constructed in such a way that you are supposed to do the 6 sets of readings. So you should record the 6 sets of readings on your table, and these are with 5 marks. Okay, so the 6 sets of readings, those are for 5 marks. So you should make sure that when you do that, you you get the 5 marks. So if you do 5 sets, you find that you get 4 marks and so forth and so on. Now, this mark also is deducted if your range is not good enough. Okay, so you should have a range. The range of your readings should span almost the whole set of the apparatus that you're supposed to be using. For example, if you are measuring along a length of a meter rule, that is, you're moving a pivot underneath the meter rule, you should make sure that you use 80% or more of that meter rule, so that you do that. And also, if you say you've got this mass spring system, you should exhaust like the masses. Suppose there are masses that are oscillating, say 3 masses or 4 masses or 5 masses. So make sure you use as many as you can, as long as it is still within the limit of proportionality of the spring. So try and utilize as much of the range as is possible. Do not use a small range. Also, if it's an electrical circuit and you're given 3 resistors, so make sure that you have the combination that gives, so this one I think I need to write it down. So suppose it's an electrical circuit. So suppose you've got 3 resistors. Now with those 3 resistors, try and come up with as many, with as much or as many combinations as you can, that is of the 3 resistors. So you could have three in series. That would be the maximum. Okay, so try and establish the maximum that you can get. So when you have got 3 resistors in series, you have the maximum value of resistance, which would mean that the minimum value of current that will be flowing in your circuit. And then the smallest possible reading that you can ever get is when you have got the 3 resistors that are going to be in parallel to each other. Okay, now once you've done that, okay, you now have values in between. Okay, you have values in between, so make sure that you have the minimum and the maximum. So the difference between these will then give you the range mark. So the range mark is when you do that. So find the minimum possible. Say it's on a meter rule, the minimum possible. Say the one that I was saying, that you've got a pivot there, and then you've got a meter rule, and you are moving masses along. So you've got masses there, and you want to measure this distance here. So make sure that you establish the minimum distance and the maximum distance before or during the experiment. Suppose this is clamped on somewhere. Just an example. Okay, and then you have a mass in the spring somewhere there. Then you're measuring this, you're measuring that. So make sure that you exhaust as much of this range as is possible as you're moving these masses along there. Okay, so find the minimum reading, find the maximum reading, and then in between you have the other 4 readings. So then you would get this range mark. Okay, so you'd get that range mark. Right, now then moving on, you do have the column headings. So your column headings should be expressed well. Okay, remember the notation that they want is L slash centimeters for length, that is, or you could have L bracket centimeters, that is for length. So make sure that you follow that. If you just write L then centimeters, that's not accepted. Okay, or L there and then you put a centimeters there, that is not accepted. So please, you should follow the notation that is allowed by Cambridge. So very, very important for you to score that mark on column headings. Also, you should take note of the units when the quantity is squared or when it is square rooted. For example, L squared there, the units should be centimeters squared, or the other notation, which is L bracket centimeter squared as well. So the units, when the quantity is squared, the units are also squared by the same amount. Also, if it is, say, L to the power half, that is the square root of L. Okay. So this would also give you a unit of centimeters to the power of half. Okay. So that is very, very important. So please make sure, sometimes these units are going to be as ratios. Say they say what is L over X at the end. So in that regard, there won't be any units for L over X if X is also measured in the same units. So very, very important. Now, before moving forward, I want to emphasize the issue of repeat readings. Okay, you should always repeat, especially when you're working with time. So time for 20 oscillations, I'll be coming back to that. But then I just need to emphasize the issue of repeat readings. I also need to emphasize the issue of stating the values, measured values to the same number of decimal places, that is consistent with the measuring instrument that is used. So we then move on to the next thing, which is the consistency mark. Okay, the consistency mark. So we have column headings, then after column headings, we've got the consistency. So for consistency, that's exactly what I mean. So L readings should always be correct to a millimeter. Okay, so L should always be correct to a millimeter. Very, very important. L should be correct to a millimeter. And then time should be correct to 0.01 of a second. Very important. I touched on this in my previous video. Please do watch that one, where I talk about measured values and calculated values. Measured values are always stated to the same precision of the instrument. That is, if it is measuring 0.01, that is the little or like the least measurement, then you should always express it in the same way. So consistency covers pretty much what I did in the first video. Okay, then we move on to SF. Now SF, we are looking at the same thing that is in the first video. That is, calculated values should be stated to the same degree of number of SF as the measured values. So that's when if there's SF values or calculated values. So calculated values must be expressed to the same number of SF. So same SF is measured values. Very important there. So same SF is the measured values. Very, very important. Right. So then we look at calculate. So we look at the calculation itself. So actually check a calculation, and then they should be done as accurately as possible. So be as accurate as possible when doing. So this should be accurate. Okay. So the going forward or going back to what we have just talked about, we have these marks. We have 6 sets of readings, right? Then after 6 sets of readings, we have got the range important. So make sure that you follow that. And then after the range, you've got column headings. Column headings must be done well. I must also state that the values of sine theta have no units. Okay, so suppose you've got theta. Theta, remember, is measured in degrees. And remember, in degrees, you don't have any decimals. And then sine theta or tan theta or cos theta will never have units. So you just leave, as well as ratios, they don't have units. So you need to leave them exactly as they are. Okay. Right. So that is that with the table. Now moving on to the graph. Moving on to the graph. The graph normally has 3 or 4 things that need to be considered. That is on the graph. I should use different ink. Right. So the graph now, we look at the axes, right? We look at the plots, right? We look at quality, and then we look at the line of best fit. Okay, so for axes, we look at the scale. So make sure you use an appropriate scale. A good scale would be, say, 1, 2, 3, 4, or multiples of that. That's 0.1, 0.2, 0.3, etc, etc. Or you can have 10, 20, 30, 40, 10, 20, 30, 40, etc. And then we have 120, 100, 200, so forth. And then you could also have for all these the same. You could also have 2, 4, 6, 8, and so forth. Same way, 0.2, 0.4, 0.6. Or you could have 0, 5, 10, 15, 20, or 0.5, or 50, or 100. So these are the scales that are the most appropriate. Now to find this, the correct or suitable scale, you look at your X readings, right? You find the maximum value and then find the minimum value. Subtract the two and divide by the number of boxes on your graph, so that your graph must occupy more than 50% of the graph grid. So find the difference between the maximum value and the minimum value, divide by the number of boxes. Look for a suitable scale among these that best suits this one. Okay. And then moving on, plots. So every point that is on the table must be plotted. Every point on the table must be plotted, and plotted correct to half a small square. Then the quality. Now, in the quality, we look at the closeness of your values to the line of best fit. So suppose you've got an anomalous point, you need to circle it. Okay, so you should circle anomalous points. So all anomalous points should be circled, so that so this is supposed to be anomalous like this. So circle all anomalous points so that you don't lose this mark of the quality. So the points must all be very close. They must be very precise. Your points should be very precise. In other words, close to each other in such a way that you can draw a line of best fit through the points with very little distance between the line of best fit and all the points, right? So you're only allowed to circle one point. Okay, so only one point is allowed there for the anomalous point. If you are to circle the second one, then you lose the quality mark. So very, very important. So when you are performing your oscillations, suppose the oscillation, make sure that your oscillations are not as big. Your amplitude of oscillations is not as big. So make sure that also there's consistency in the way you're performing your experiment, because this will reflect on the graph if at all your procedure was different. So say you had 5 degrees for your oscillations, then the next set of readings have 25 degrees. You find that you won't have a correlation in your readings. So there must be good correlation among your points. Then we have the line of best fit. Now in the line of best fit, you must make sure that there is an equal balance of points on the left side, on the right side of your line of best fit. Okay, so must be good balance of points on the left side and on the right side for you to score this mark. Also on your graph, you should have you should have a triangle. Okay, so a triangle that will allow you to draw the gradient, or to calculate your gradient. So this triangle must be larger, must be, yes, about 50% of your graph, occupy about 50% of the line. Okay, so very, very important. So maybe at this juncture, I should just show how it will be done. Okay, so suppose you have plotted t squared second squared versus L in meters. Again, for your x's mark, you need to label the x's. Very, very important. If you don't label the x's, you lose a mark. Units are not that important on the graph, but on the table, very, very important. But it's always good practice to also include the units. Now, suppose you've got your line of best fit drawn like this, right? So I was saying that your points should be balanced along the line of best fit. Okay, so they must be like that, very close to each other. If you happen to have, so remember there must be 6. I was just showing, overemphasizing. So suppose you don't want this point because it is far away from this point here, you can circle it so that it won't be regarded for your line of best fit, so that you get the quality mark. Now, your graph should have a good, remember I said it must be going this way, it must be a good scale, as well as going that way, it must be a good scale. Very, very good. And the gradient the triangle should occupy more than 50% of your graph, so that you take this coordinate there, you take that coordinate over there, and then you use that in your grad calculation. Now, last thing we're going to look at in this video is the calculations. Okay, so in the calculations, remember, for the gradient, you are going to use the coordinates from your triangle. Okay, so if you do not have this triangle, it's very hard for you to be awarded this mark because you won't be able to get the coordinates right. So it has to be very, very important. This triangle method is very, very important. Now, I recommend students to put the units again of the gradient so that it becomes easy for you when you're now calculating or finding the unit, the constants that you want to find in the practical. So units of gradient are very important, but well, if you don't record them, you won't lose a mark. Then the y-intercept. Now, in the y-intercept, you can either read, that is, if your x-axis is starting from 0, okay? So starting from 0. Now, if it's not starting from 0, you cannot read, obviously, from your y-axis because that will be a false origin. Now, what you do, you need to calculate your intercept if in that case. So calculating the intercept, you find that you'd get, in the form y is equal to mx plus c, because this is a straight line graph, so c will be equal to y minus mx. Now, your value of x there should be equal to 0. And okay, when you have got c, that is if you are starting from 0. But now if you're not starting from 0, you pick a coordinate that is lying on the line of best fit. So you pick a coordinate exactly on the line of best fit, and then you input the x value there, and then you input the y value there, and then the gradient, since you've calculated it, you also input it there, and then you can find your y-intercept in that regard, right? Now the last thing here is the constants themselves. Usually one of the constants is equal to the gradient, or it's related to the gradient, right? And then another constant is related to the y-intercept. Okay, so I'll just put it random. So constant p should be equal to the gradient, and then you should then state the unit of p. Okay, then so very, very important there, and also to the same degree of accuracy. Now, the precision, or let's say the number of SF for your gradient, right? Number of SF for your gradient is dependent on the y divided by the x. So what you've plotted on the y-axis divided by what you have plotted on the x. So the units, okay, are what we are talking about here. So the units of y over units of x. So suppose if x is to 2SF and then y is to 3SF. So you express your gradient to 2SF there to be consistent with the least. So you cannot be more accurate than the least degree of accuracy in the calculation. So you state your gradient to 2SF. So which means the value of p, the constant that we've mentioned earlier, must also be to 2SF and also with the respective units. So to get the units of the gradient, the units on the y divided by the units on the x. Okay, so suppose these are seconds squared, and then these are meters, so which means second squared meter to the minus 1. Okay, second squared meter to the minus. So that's how you can identify the units of the gradient. Now the units of the y-intercept are the same as the units of the y-axis. Okay, that would be second squared in this sense. Okay, now which means that the second constant that you would want to find, which would be p, which should be q. Okay, so q would be equal to the y-intercept in most cases, and the units of q must equal units of intercept. Now, suppose q is not equal to the y-intercept, or p is not equal, which means you use the formula y is equal to mx plus c to establish the relationship between p and q. Okay, so m should be related to the first constant. It may be 1 over gradient, or it may be gradient over something, and then c is always related to the other constant, okay, which is your intercept. I hope this video has helped, and if you need further assistance, please write in the comment section. Remember to like, share, comment, and subscribe to the physics tips for IGCSE and A-level physics Cambridge students YouTube channel. Signing out.